Hi, welcome to Math 196, Spring 2014. I am Professor Branson, and I'll be making these videos to go over some of the material for this class. This first video is on distribution and factoring, so Appendices sections A2 and A3. So what we'll do, the way these videos go, is this will be an example, say distribution with parentheses, and along with that is a list of problems. Here, problems 9, 10, 11, 12, 31, and 32 in section A2. Those are like this example that I'm about to do. And so once you've seen this example, you should be able to go ahead and do those problems. So this is a review, kind of a review problem, right? Order of operations, example 1. Multiply this out and simplify it. So what's going on here? What we want to start with is start inside. So you always start with the inner parentheses. Okay. And so we'll start here. What do I need to do is take this minus 2 and distribute it to the x and to the 1. And so what does that give me? Well, I'll keep the beginning of this. So 2x plus 3, open this parentheses. X minus 4, open this parentheses, and then I get x minus 2 times x is a minus 2, and then minus 2 times a 1 is a minus 2. And 1, 1, 2, I need 2 parentheses there. Right. So this minus 2 distributes to the x and then to the 1, and I get a minus 2x and a minus 2. And the parentheses go away when I do the distribution, right? So we've gone from having 3 pairs of parentheses to having just 2. And now we can simplify this part, right? The innermost parentheses. There we go. So x minus 2x, well, we'll keep the beginning parts. 2x plus 3, x minus 4, x minus 2x, that's a minus x, and minus 2, that's just a minus 2. And that there is a parentheses. Okay, now what do? Well, we take our minus 4 here and distribute that to the minus x and to the minus 2. Again, we always work on the inner parentheses and we distribute something over it. Once we've distributed, the parentheses go away. So 2x plus 3, then we have my x, minus 4 times minus x, that's a plus 4x, because minus times minus gives me a plus. Minus 4 times minus 2, that's a plus 8. And again, the parentheses, these two parentheses have gone away, and we're just left with these parentheses now, since we did the distribution. And then simplify again. So 2x plus 3, x plus 4x, that's a 5x, and this is a parentheses, and then the plus 8. And now we can distribute the 3. The plus 3 gets distributed to both sides. Not to both sides, but to both things inside this last parentheses. 3 times 5x, that's a 15x. 3 times 8 is 24. And we can simplify a little bit more. 2x plus 15x is 17x, and then 24. So parentheses aren't too bad when we're doing our simplification. Just remember, you always start with the inner parentheses wherever you are, distribute whatever the number is times it, and so this minus 2 gives you minus 2x and then a minus 2, and then simplify what's in the parentheses you're in. And once you've done the distribution, the parentheses go away. Okay, so that's one example. And so having seen that, right, these problems here, those are all sort of along these lines. You have a bunch of parentheses. You just need to be a little bit careful about keeping track of what you're doing to multiply those out. Okay, so distribution of multinomials. Multinomial is just having a number of things inside of a parentheses. So binomials, right? Bi means 2, so a plus b times c plus d. That's a pair of binomials, right? There's two things inside each of those parentheses. So if you multiply this out, what do you have to do? Distribute the a times to the c, and the a to the d. So a times c is a times c. A times d is, well, a times d. And then you distribute the b to the c and the b to the d. So plus bc plus bd. This you may have seen before as FOIL, right? First, outer, inner, last. So a times c, that's first. A times d, that's outer. B times c, it's inner. B times d is last. So the a gets multiplied to the c, the a gets multiplied to the d, the b gets multiplied to the c, the b gets multiplied to the d. And again, when I'm doing these videos, once I've done the distribution multinomials, these problems, these are the homework problems, in section 8.2, you should be able to do those. Okay, so here's an example of a pair of binomials, 2x plus 3, 4x minus 2. There's two things in each thing. Note, we should get four terms, right? Because we're going to do this times these two, so the 2x times these two, that's two terms, and then 3 times these two terms, that also give me another 3 terms. And I'm going to organize this in a particular way. So we'll start with my 2x times 4x, that's an 8x squared, and then the 2x times the minus 2, that's a minus 4x. That's my first and outer, that's distributing the 2x, and then 3 times 4x, that's a 12x. I'm actually going to write it underneath the minus 4x so that I get the x's to line up, and then I have a 3 times minus 2, that's a minus 6. And so there's my 4 terms, and I can add them up now. So 8x squared plus 0x squared, that's an 8x squared, plus 12 minus 4, that's an 8x minus 6. So when I multiply this out, I get 8x squared plus 8x minus 6. I get 3 terms in the final answer because these two combined to give me the 8x. Writing them in this way so that you have one row for the distribution of the 2x and then one row for the distribution of the 3 helps a little bit in figuring out, if you made a mistake, where that mistake might be. Okay, so did we have... Oh. Yeah, so that's a pretty straight example. I think I might have forgotten to put in an extra example. So we'll just put this in here. We'll call it example 2a. Suppose we want 2x plus 3 times the quantity x squared plus 4x plus 5. Right? Now this is a binomial, there's 2 terms. This is a trinomial because there's 3 terms. How many terms do you get? 6 terms total when you multiply this out, because the 2x times each of these 3, that'll give you 3 terms, and then the 3 times each of these 3, that would also give you 3 terms. So 2x times x squared, that's a 2x cubed. 2x times 4x, that's an 8x squared. 2x times 5, that's a 10x. 3 times x squared, that's a 3x squared. 3 times 4x, that's a 12x. 3 times 5, that's a 15. And note that I'm trying to write these things. The first row here is multiplications by 2x. That's what I get when I distribute the 2x. The second row is what I get when I distribute the 3. And I line them up by powers of x. And now, to get the final answer, we just add them all together. 2x cubed plus 11x squared plus 22x plus 15. And there's our final answer. And note, when we multiplied everything out, we got 6 terms, but these two combined to give me a new 1 term, and these two combined to give me 1 term. Okay. And now we can go into special cases. One is this, right? So note that when you have anything squared, right, that's itself times itself. So a plus b quantity squared is a plus b times a plus b. If you FOIL that out, You get a times a, that's a squared, plus a times b. That's the distribution of a. Distributing the b gives me a times b, right? That's these two multiplied together plus b squared. And so there is my squared binomial. So it comes up a lot. Just remember that if you have something squared, right, it's itself times itself. If there's a plus inside of the parentheses, you have to FOIL it out like that. So 2x plus 3y squared, what's that? 2x plus 3y squared is 2x plus 3y times itself. So distribute the 2x. 2x times 2x is 4x squared. 2x times 3y is 6xy. 3y times 2x, well, that's another 6xy. And then 3y times 3y is 9y squared. Add those up. We get 4x squared plus 12xy plus 9y squared. Okay, so that's one special case when you have a binomial squared, right? Remember, multiply by itself. And if it's cubed or to the fourth power, you'd still have to do the same thing, but you'd have to multiply it over and over again. Conjugates. Conjugates are a binomial, two of them, with exactly the same terms, a and a, b and b, except one's a plus and one's a minus. And then you get a very nice thing here that happens. A plus b times a minus b. If we multiply this out, we distribute the a's, we get an a squared. Then a times minus b is minus ab. Distribute the b, b times a is a plus ab. And then b times minus b is a minus b squared. So when you add them up, what do you get? You get an a squared there. These two cancel out. One's a plus, one's a minus, and they're both the same thing, minus b squared. So a plus b times a minus b, that gives you a squared minus b squared. Which means this is a little bit easier to deal with. You don't actually have to multiply it out. If you recognize that these are conjugates, it's the same thing, except one's got a plus and one's got a minus. So you square them and subtract. So square the first, square the second, and subtract what's inside. There you go. 4x squared minus 25y squared. And so that's the second case of conjugates. So that is really distribution of multinomials. You should be able to do these problems now, because really you just take each term in the left-hand one, right, the 2x, and you multiply by each of those, and that gives you one row, and you take the 3, you multiply by each of those in the second, and that gives you another row, and you add them up. Right? Same thing here. Take the 2x, multiply by each term over here, that gives you this. Take the 3, multiply by each term up there, that gives you this row, add them up. So factoring, not factoring, distribution is not too bad. Factoring is the next thing that we're looking at. There it is, factoring. And a little bit of space here so that I can talk about this. This is the inverse of distribution. Right? So what do I mean by inverse? Well, distribution means take something and multiply it out. Right? The inverse of distribution is go backwards from the result to where you started. Undistribute. Right? We know if you had, say, x plus 2 times x plus 3, if you multiply that out, you get an x squared plus 5x plus 6. That's distribution. What we want to be able to do when we're factoring is to be able to say, well, if you start with x squared plus 5x plus 6, I can turn that into x plus 2 times x plus 3. It's really the same equation, right? It's just how you're going to read it left to right or right to left, right? X plus 2 times x plus 3. If you multiply that out, if you distribute, you get this. If you take x squared plus 5x plus 6 and you factor it, you get that. Okay, so how do you factor things, right? I mean, this was easy. Factoring this is easy because I'd actually multiplied it out. But suppose you wanted to factor something like 10x squared minus 13x minus 3. Right? Can you figure out what that might be? Right? Can you pull that apart? Okay, so factoring means pulling stuff out to create a couple of things multiplied together, right? It's the inverse of distribution. Okay, so one idea is just a common factor, right? And again, section A3, 1, 2, 6, 9, right? Those are all common factor problems. So here's a expression, 12x to the fourth plus 8x cubed plus 4x. What is common? Well, there's a 4 and an x, right? So what is this? If I take a 4x out of here, 12 divided by 4 is 3. And if I take an x out of x to the fourth, I'm left with x cubed. If I take 4 out of 8, 8 divided by 4 is 2. And if I take 1x out of x cubed, I'm left with 2 x's. And if I take a 4 out of 4, I'm left with 1. If I take an x out of x, I'm left with 1. So plus 1. So factoring out common terms just means what is in each and every term that I can then, factor out. And you can always check if you're ever unsure about your factoring by distributing. Right? If you multiply it out, 4x times 3x cubed, that's 12x to the fourth. 4x times 2x squared, that's 8x cubed. And then 4x times 1, that's 4x. Right? That's what we started with. And so and we got what we started with. So we did our factoring correctly. Anytime you factor, you can always check your answer just by multiplying it out, by distributing, and see what you get. And you should always come back to where you started with. So this and this are equal because we just factored out the 4x. Okay, so here's another thing. What's a common term here? Well, this has got an x cubed and a 2x plus 3. This has got an x squared and a 2x plus 3. This has got a 2x. This has got a 3. A little bit tricky here because what we actually have, if we rewrite this, is there's one term and then a second term. And it looks like we have two more terms, a 2x and a 3, but we can actually, if we put a parentheses around it, just say, well, we actually only have 3 terms there. This is all one term, this is all one term, this is all one term. So we regroup this 2x plus 3 inside of parentheses, and now we see that what's common to each is they each have a 2x plus 3 in it. So I can take that out. Right? My common term can come out front. And then what's left behind? Well, if I take the 2x plus 3 out of here, what's left behind is the x cubed. If I take the 2x plus 3 out of here, what's left behind is the x squared. If I take 2x plus 3 out of 2x plus 3, what's left behind is 1. Right? And remember that every time you pull everything out of a term, right, you're left behind with 1. And you can check that, again, by distributing. Oops, a little bit further than I wanted to go. Right? 2x plus 3 times x cubed. 2x plus 3 times x squared, that's this term, and then 2x plus 3 times 1, well, that's just 2x plus 3. And so that tells us that we factored it out correctly. So you should give a try now to these 4 problems, right, because those are common factor problems. Okay. Grouping. Right? So A3, 10, 13, and 14, those are all grouping problems. And grouping problems are ones where it's not really obvious what you can pull out, but you can pull out something from some of them. So what do we got here? Looking at this problem, these two terms have an x in common. These two terms have a 3 in common. So let me factor the x out of the first two terms. And if I factor an x out of x squared, I'm left with x. And if I factor an x out of xy, if I take the x out of that, the y stays behind. This is supposed to be an x. I didn't know what the heck that was. X, there we go. If I factor 3 out of here, right, what's left behind? Well, take the 3 out of 3x, you're left with an x. Take the 3 out of y, you're left with a y. Right? Ah, now, okay, you can see that there's something useful going on here as well. Right? X plus y now is common to both. So we can factor that out. If we take out the x plus y, out of this term, what's left behind is the x. And what's left behind, if we take the x plus y out of there, is the plus 3. So, oops, let's just make that really look like a y and not a 4. X plus y times x plus 3. So you can factor out a common term out of these first two and a common term out of these second two, and then lo and behold, you have a common term in each of the two new terms that you get, and then you can factor that out, and you're left with the x plus 3 times x plus y. This doesn't always work, of course, right? You can try and factor things out, and you won't get something that's the same in both cases, but it happens often enough that it's a useful thing to think about. And it happens very often, in fact all the time, when we do something called the AC method, which, here we are. So problems 19 through 30 and 33 through 6 in A3 is all quadratic factoring in the AC method. So we'll do an example of factoring, quadratic factoring, and we will then explain a little bit about why it works, and then I'll talk about the AC method. So factor this. How do I factor x squared plus 5x plus 6? Well, I want two numbers add to 5, multiply to 6. Right? So that's the trick, is you want to be able to find two numbers that multiply to give you a constant and add to give you to the coefficient of x. So what numbers multiply to give you 6? Well, 6 times 1 is 6, 2 times 3 is 6. So we can either have the pair 6 and 1, but those add to 7, that doesn't work. Or we're going to have the pair 3 and 2. And 3 and 2, 2 plus 3 equals 5. So now we've got our factor. So x squared plus 5x plus 6, once you factor it, is x plus 2 times x plus 3. Well, are we right? Well, again, you can always check by distributing. X plus 2 times x plus 3 is what? We'll put a little bar here so that we know what's going on. Well, we get x times x is x squared, x times 3 is 3x, 2 times x is 2x, 2 times 3 is 6, x squared plus 5x plus 6. And now we see why we needed the multiply to 6, right? These two terms, when they multiply together, they give you the constant term, which is 6. Why do we need them to add to 5? Well, inner 2x, that's here, and outer, that's 3x, that's there, they add together when we after we distribute, and that gives us the 5x, 3 plus 2. So why does this factoring work? Let me slide up a little bit here. If I take two binomials and multiply them out, what do I get? X times x is x squared, x times b, that's bx, a times x is ax, and then a times b is ab. Oop. So x squared plus, if you add these together, you get a plus b times x plus ab. So to factor a quadratic into two terms, x plus a times x plus b, the middle term has to be the sum of these two, so a plus b, and the constant term, that's this one, has to be this number times that number. So where's my notes? There we go. So there's a quick example. we can do, what the heck, we'll do one more example here. What example am I at? We'll call it example 8a. Right? X squared minus x minus 6. So add 2 minus 1, multiply 2 minus 6. Right? And so what are my options here? Well, multiply to minus 6. That's minus 6 is, well, it could be minus 6 times 1, or 1 times minus 6. It could be minus 2 times 3, or 3 times minus 2. Right? So there's really 4 options here, taking into account the signs. Minus 6 plus 1, that's minus 5. 1 plus minus 6. No, minus 6 plus 1. Oh, we want a minus sign there. Erase that one. There we go. Minus 1 times 6. This adds to minus 5. This adds to 5. Minus 2 times 3. That adds to plus 1. 3 plus minus 2. That adds to minus 1. So then we can factor, because we have two numbers that add to minus 1, multiply to minus 6. X squared minus x minus 6 is x plus 3 times x minus 2. And if you distribute that, you can see how that works. Okay, so a slightly harder problem now is, what do you do if the coefficient of x squared is not 1? Here it's 6. Well, we really do the same thing. This is called the AC method. That's how the book refers to it. Take the first number and the last number, traditionally called A and C. What's A times C? A times C is 6 times minus 15. And A times C is minus 90. Right? So A times C, 6 times minus 15. So what we want to do now is the same thing, except we want to be able to find numbers that add to minus 1 that add to minus 1, multiply to minus 90. So it's the same procedure as before, except instead of just using the last term, we take the last term and we multiply by 6. And then, we multiply by the coefficient of the x squared, and then that'll let us figure out what the number that we're looking for is. So you can list all the products of minus 90, right? It's minus 90 times 1, or minus 1 times 90, minus 45 times 2, or minus 2 times 45. But we know 10 times minus 9 equals minus 90. 10 plus minus 9 equals minus, got the minus sign in the wrong number. Minus 10 times 9 is minus 90. Minus 10 plus 9 is minus 1. So the two numbers we're looking for are minus 10 and 9. Now we can't just go and put them back into the factors like this, because we still have to worry about what is the product on the first. So why are we interested in this? Well, we know that minus 1 times x now is minus 10 plus 9 times x, because minus 10 plus 9 is minus 1, or minus 10x plus 9x. And that's useful because now we can replace this minus x by minus 10x plus 9x. So we'll just finish this off. We started with this, what was it, minus 15? And we said, well, the minus x we can replace. We got this minus 10 and 9, 6x squared minus 10x plus 9x, and then the minus 15. Why is that useful? Well, now we can factor by grouping. right? Just as we did above. What's common to these first two terms is two x, right? Because there's a 6 is 2 times 3, 10 is 5 times 2, and common here is just 3, right? 9 is 3 times 3, 15 is 5 times 3. So our 6x squared minus x minus 15 is equal to, if we factor out the 2x, what's left behind here is a 3x. Right? 6 divided by 2 is 3. X squared, if you take 1x, you're left out with you're left with 1x. And then 10x, if I take out a 2x, I'm going to be left with a 5 there. Okay, now if we take out a 3 out of this, what's left behind? Well, 9 divided by 3 is 3. 15 divided by 3 is 5. And that, if you pick your numbers correctly, should always happen. You should always be able to get a grouping factorization to work here in the AC method. So if I factor out the 3x minus 5, what's left behind is the 2x plus 3. And so there we've got it. And if you multiply it out, you get your 6x squared, that's this times this, minus 15. And then you have a 9x minus 10x. Right? That's what we had there. So that's factoring. And you should be able to do all the problems now in sections A2 and A3. Right? So factoring is those. Okay, so that's the end of this video. Remember, as you go through the videos, I'll point out which problems you can that go along with which examples, and then once you see an example, you should go and work on the problems a little bit and